the course trajectory. On Monday, we talked just in general about stormwater, green infrastructure, right? Tuesday, we talked about how well these practices work, but then a focus of a practice that you can use for treating rooftop runoff. All right. Yesterday, we spent our day talking about permeable pavement. And a big part because on this campus, permeable pavement would have some legit opportunity to be used. Permeable pavement and rainwater harvesting are considered sort of smaller scale, or you may have heard the term low impact development practices, so site scale. What we talk about today are more basin practices, bigger practices that you probably won't find a space for on campus, but you might find space for them on the outskirts of town, in the peri-urban areas. And how many of you expect to work in designing the infrastructure for some of the new construction that is coming to places like Delhi and Bangalore, right? I think a lot of you will, right? And so in those particular places, you have opportunities to create these large practices that can serve as amenities. So now that I've started on my watch, I'm going to give myself an hour. When the alarm goes off, we'll take a break. Okay. So there's three large, or what people might refer to as basin stormwater control measures. The most common in more humid areas of North America is something called a wet pond. It's not necessarily an attractive practice, but some of them are. Then in areas that are either drier or you are pretty far from the water table, you'll have something called a dry pond. They tend to be a little bit smaller than wet ponds, but not always. And then last but not least, there's a practice called a constructed stormwater wetland. Now, I'm going to talk in the order in which I'm going to speak of them. We're going to start with dry ponds, migrate to wet ponds, and then close and spill over into the second presentation on stormwater wetlands. So here's an example of a dry pond. It is exactly like it sounds. It's dry, unless it's raining. And then water will fill up this basin and then be gone about 24 hours later. Here's a dry pond that they built in Sweden. You see what they decided to turn their dry pond into during times when it wasn't raining. They have a little soccer pitch, all right? And to encourage you to always be mindful of what your footprint of your practice could also be at times it's not raining. Here is a dry pond that our Ministry of Transportation put in, and they decided to go ahead and let trees grow up in it, all right? It actually is not a bad idea if people don't mind that look, all right? Here's another one that our transportation ministry put into the ground, all right? Here's another one, not a particularly attractive practice, all right? But if you're just trying to hold water to reduce flooding, then this stormwater control measure may make sense. Here's a more attractive one. This is out in Denver, Colorado, where it's quite dry, all right? It's a semi-arid state, and so they've turned their dry pond into a relatively aesthetically pleasing stormwater control measure. Here's one in northern Ohio where there's snow, and that's why that particular plant is able to survive. And here's one where my children are out there trying to figure out how it works. How many of you liked exploring things when you were little? Thank you, those of you put up your hands. I did too. Look, there's a lot of parents nowadays like, oh, no, don't do that, don't do that. That's not me, man. I'm like, get out there and figure your stuff out, buddies. You see that hole? That's important. That's the drawdown orifice. And so what makes a dry pond and not a wet pond is this orifice right here. Remember, we talked about orify, that's engineering for hole because it makes it sound a little smarter. All right. But where's that hole located? At the bottom, right? And that's why it's called a dry pond, because the water gets drawn out from the bottom, and therefore it is relatively dry. Most of it actually is dry. There'll be some wet spots, but most of it is dry. And so this is a potential practice that you might be interested in if you don't want to have ponding water around. All right. And there are times where that is the case. All right. Here's another couple of dry detention basin outlets. This one here, bunch of small little holes that slowly drain the water down, higher drainage rates at the beginning, lower drainage rates at the end. And then here's another one. You see a couple of bricks that they just didn't include. All right. So these are all different, but note, all of them have drawdown orifices all the way to the bottom of the basin. All right. So what are some things that you observed when I went through those pictures of dry ponds? What'd you see about them? What's Say it again? Yeah, so they're all, almost every picture I showed you, they were dry, right? There wasn't ponded water. That's a big one. The holes at the bottom. Would you say that they were aesthetically pleasing? I'm with you, IIT Bombay. I think they're not particularly. I mean, if you try really hard, you can make them, but I don't think they look that great. All right. But their role is to mitigate. Yes, sir. Let me get over closer so I can hear you better. Me and my little T. Oh, yeah. That's actually going to be a big point for here. Basically, I think I hear you say that you have some concern that the holes could clog in the outlet structure. Yeah, I would agree. That's something I think about a lot for here, is that some of those holes are apt to clog. All right, those are all quite good. This is a schematic. Engineers love our schematics. Here's the pool. They basically would allow up to 3 meters of water to pond. And here's that little itty bitty hole that would dewater this pool over the course of 2 to 5 days. All right. You're going to hear this a lot, that a storm, and it's not just a storm, it's the water quality storm. So if it rained 35 millimeters, the idea is this dry pond would hold that water for 2 to 5 days before it's all gone. Okay? That's how a dry pond is designed to work. Why do you think that the American design standard is you hold the water for 2 to 5 days? And I'm not saying that's the ideal design standard for here. I'm just saying that's what we use in the US. Why they want you to hold the water quality storm and have that volume of water drain out over the course of a 2 to 5 day window. What's one reason to hold the water for 2 to 5 days? You want to make sure what? I think you're right. Let me hear it one more time.
I'm saying so to let the sediment settle down.
Okay, great. So you have to hold the water in there long enough so that the pollutants can fall out, all right? So sedimentation can occur. And that is one of the 2 reasons. You need to hold it 2 to 5 days so that pollutants will fall out, all right? Sedimentation can occur. Some amount of sedimentation can occur. Why don't you think they say, well, let's hold it for 15 days? Because you get more sedimentation. So why is there a limit on 5 days? That could be, that could be correct. That's not the reason they choose it, but that does make sense. That the particles would all be gone in 5 days. So why bother to do more? More is overkill. That makes sense. That's not the reason, but that does make sense. I heard so many probably right answers. We'll go with you. Oh, that's a good reason. Yeah. Mosquito control. That is a good reason. Mosquitoes, a nice rule of thumb is that they need 7 days straight of ponded water. Okay. There are a few species that can make do with 5. So this would align with mosquito control. In North America, that is a part of the thinking process. It is a part of the thinking process. That's probably not the reason, but it happens to be a reason that it is good, that the 2 to 5 day drawdown is good. So mosquito control, that's a good answer. Another answer. Financially, okay. So meaning that maybe some of your practice might have to be a little bit bigger if you had to go for 15 days. There's some truth to that as it relates to the other main reason. The other main reason is guess how often it rains in North America, in eastern North America. It rains roughly every 3 days. Okay? Unlike here, where you have a monsoon and the rains just keep coming, okay? In North America, not all, but most rain is associated with fronts that travel across the continent. And guess how long it takes a front to travel across the continent? 3 days. Okay? And so that's why we pick 2 to 5 days. All right? You want to give your designer some flexibility. All right? But 3 days means that when it rains the next time, you have created extra capacity. You have capacity in your basin to handle the next storm. All right? If you're worried about mosquito control, which we should, having it draw down faster, 2 to 3 days, will help keep mosquito populations from flourishing. And last but not least, you want at least 2 days because you want some sedimentation to occur. You get 5 days, you get more sedimentation to occur. And while we'd love to have 15 days to really kind of max out sedimentation, because of the other constraints, we just can't let it go for 15 days. So it is a balancing act of those 3 things: storms, mosquitoes, and pollutant removal. All right. Now, I went through that with this is how dry ponds work. I'm not going to spend a ton of time on dry ponds here. This is pretty much it. Other than to say that one of the main, oh man, I forgot to change. I'll speak these to you in SI units. All right. Forgot to change this slide into SI units. So one of the things about a dry pond, which makes it a little less likely to be used in rookie, is that the dry pond has to stay dry. So that means it has to be located above the seasonally high water table. All right. Dry ponds tend to be deeper systems. They tend to be 2, 3 meters deep, which means that if you put your dry pond in somewhere here in rookie, you would need to have 2 to 3 meters, but really 3 meters between you and the seasonally high water table. That's not going to happen a lot. All right. So that's one of the reasons why we don't talk about it too much. Again, they allow the water to go up 3 meters. And I'm going to hit some of these other ones in a little bit. The drawdown time of 2 to 5 days. And they want to make sure that it is appropriately vegetated. Okay? So those are the key points associated with designing a dry pond. Some of you may be doing work in a location where you do have some separation between you and the seasonally high water table. and you want to find a practice that doesn't pond water in all the time. And so this might be a practice for you to choose. So if you want to sum it all up, it rains, the water goes in, fills it up, and then over the course of 2 to 5 days, it draws out through the orifice. That, y'all, is a dry pond. Are you ready to move to the next one? Okay. Let's talk what dry ponds are good at what? You put a dry pond in, what's one thing you feel pretty confident it can do from a hydrologic or water quality standpoint? What's that? Yes, that is the main thing they're good at. Do y'all use the term one-trick pony? You ever heard that term? That's a one-trick pony. It means you've got a pony and you've taught it to do one thing. Let's say your horse, you get up on its hind legs and prance around. You're like, oh, that's cool. Does it have any other tricks? And the answer is no. But it's really good at getting up and prancing around. That's its one trick. That's what the dry pond is. It's a one-trick pony. It is good at peak flow mitigation. It isn't particularly good at anything else, including sedimentation. All right? Because, and tell me why. Why do you think it's not as good at sedimentation as the next two practices? Sediment comes in. It hangs around, let's say, for 5 days. Does it fall out during that 5 days? Yes. Some of it falls out during that 5 days. Then what happens next time it rains? You ready for this one? It resuspends some of that sediment that just fell out 3 days ago. All right? And so you have this constant, there is accumulation of sediment, but it's slower in a dry pond than it is for the other practices because of this dynamic of settling. It's still for a few days, it rains again, it resuspends. It's like it just keeps doing this. Some of it does accumulate, but it's not as good as accumulating. So those are the things it struggles. It's not particularly good at removing pollutants, which is why we have wet ponds, which are better at removing pollutants, and wet ponds are also very good at mitigating peak flows. So this is more than a one-trick pony. Let's take a look at a few of them. This one here is actually in Sweden, all right? They have something called a vegetative shelf. I'm going to talk a little bit more about vegetative shelf design in a little bit because I think it's important for all of us to know. But the vegetative shelf is this right here. It's that border region along a pond that has vegetation, all right? What benefits do you think that vegetation provides? Actually, sit on that. I'll come back to you in a little bit. We'll talk about that in a little bit. Here's one that there is no vegetated shelf, not particularly. And would you say that's a good-looking pond? Is this a good-looking pond here? Yeah, I agree. That's pretty good. You could use that as an amenity. Is this a good-looking pond here? That's fine. I don't think it is either. Guess what? It wasn't an amenity. All right. So you have this ability with dry ponds and with wetlands, for that matter. They both can be designed and then maintained as an amenity, or you can stick them out back, not care about them, and they look something more like this, which I would think would actually devalue property. But I don't manage the neighborhood association, so who knows? Recreational features, larger ponds especially. If you take a look, you'll see a path, a concrete path, sidewalk, that goes in and around this pond. So again, this is an amenity with a recreational benefit, all right? So just always be remembering that. Particularly, I keep thinking about the drive that Fernando and I took up from Delhi, New Delhi. We passed New Delhi to get up here. I saw all this new development going by, multi-story, tall buildings, 30 stories tall, lots of people living. You got to manage the stormwater from that. What if you create a very attractive pond for them to be able to walk around? I'm just saying that might be something you're interested in doing, all right? So of all the bigger SCMs, meaning dry ponds, wet ponds and constructed wetlands, the most popular one of these is by far a wet pond. All right, you guys ready? This is fun. North Carolina. North Carolina, I don't know the size of the Indian states very well at all. Well, I do know that North Carolina and England, not Great Britain, but England, are almost the exact same size. Okay? To give you some idea, North Carolina and England are about the exact same size. England has 5 times more people. Okay? Guess how many wet ponds are just in the state of North Carolina? How many wet ponds that have been put in to treat stormwater runoff, how many of them are just in the state of North Carolina? I'm going to have one of you give me one answer, and then we're going to go from there. Take a guess. Just any number. 50. Okay. 50, 50. That's good. So you guys, everyone has to vote. Thank you for volunteering an answer. Everyone has to vote. You can either say 50 or fewer, okay, or more than 50. All right? How many of you guess that there are 50 or fewer ponds in North Carolina? Okay. How many of you, therefore, a few of you, okay. So you did not vote for 50. You're going to vote for more than 50. Okay. How many say more than 50? So the man who said 50 is actually saying more than 50. Well, that was correct. The answer is somewhere between 10 and 15,000. Okay? 10 and 15,000. All right? Just to give you, and that's in one state. That's in one state. The state to the south of us, they claim they have 40, and that's even smaller than North Carolina. Guess what it's called? The state to the south of North Carolina is called South Carolina. That's correct. The South Carolinians claim they have 40,000 wet ponds. Now, that may be true because South Carolina doesn't use a variety of, North Carolina does actually use a variety of practices. We have thousands of bioretention cells in North Carolina. We've got hundreds of constructed wetlands. We've got thousands of samples. We have a lot of other practices that we do use in our state. But 40,000 state, probably closer to 15,000 in North Carolina. In other words, I never have an issue finding a good picture of a wet pond. I've got tons of wet ponds. And I would argue that for those of us in the engineering world, wet ponds in the hydroengineering world in the southeast US, wet ponds are boring. Because they're everywhere. There's not a lot that's fancy about them. So that's when I say they're the dominant force in humid North America. So we're putting 15,000 of them in, right? Do they work? That's a legit question to ask, right? May I get some tea, please? I'm loving it. It's good to have a friend. How many of you guys have friends that would pour you tea? Probably all of you have friends that would pour you tea, right? And actually, he's not even going to pour it. I'm gonna do it. That's funny. Okay. Thank you, sir. Mr. Fernando and I have gotten to go all over the world, haven't we, Sean? We're enjoying our time in Rookie, aren't we? Good people. So it makes a good spot. Good places, good people, and having things to do. I have things to do every day. Teach. Teach, teach, teach. Okay. Here's a pond. This is a classic American neighborhood. You see the box store. This is how we get our groceries. We call that a parking lot. Y'all can call it a car park. And then here's the pond. All right. This is what it looks like. Does it look good from the air? You can be honest. It's not going to hurt my feelings. No, it doesn't look particularly good from the air. But does it work? There's your inlet concentration, and there's your outlet concentration. And it is good at sediment removal, right? 74% sediment removal. It's, yeah, is it good for phosphorus removal? Not really, though to be fair, the concentrations coming in are pretty low. Is it good for nitrogen removal? Not really, but the concentrations coming in are pretty low. My children would call it sus. It's a little sus, Dad. You ever heard that term? It means suspect. Do you use the word sus sometimes? That's sus, Dad. Okay. Here's another one since we're on a roll. Similar, this is for a townhome community. And in this particular case, a little bit better nitrogen removal, still good sediment removal, a little better phosphorus removal. And so it does okay. It's okay. Here's another one we studied up in our foothills. All right. You can see the outlet structure there. And this particular one, we were looking at temperature coming in and temperature leaving. So the yellow bar is the temperature leaving. The blue bar is the temperature of the runoff. And then the inlet water is in this red, kind of like my awesome hat, and then light blue bars. And what do you see about the thermal situation leaving the pond? Is the pond good for cooling the water off? In a word, nope. It's hotter. The hottest temperatures on average in each of those months is not associated with runs off the parking lot or the car park. It's associated with what leaves the pond. Why do you think that's the case? How many of you go to the beach and sunbathe? Is that a thing? People go out to the beach. Like Mr. Fernando here, he used to live near the beach. And you go out, you take a book, right? Sit in the beach on the sand and read. Is that something Indians do? Is that something you guys do? Well, when you come to America, some of you might come to America someday, right? For about 4 of you, it was a bucket list destination. Thank you. I'll never forget that. Thank you. You go to the beach. You want to take a day at the beach. You take a book. You go to Miami. Go out to the beach. Take a book. And for the guys, this is what the guys do. They take their book. We know what the guys are really doing. Looking at all the girls that are passing by. I don't know about the girls because I'm not a girl. I don't know. Okay. Where was I going here? Oh, sunbathe. What's the water doing in a pond all day? Sunbathing. It's exposed to the sunlight. And then in the afternoon, here comes the storm. Na 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 na. And what happens then? All this water that's been baking all day long, whoop, gets pushed out. And that's why the hottest temperatures associated with this graph are all associated with the outflow of the pond. Do you think ponds are a good practice if you're worried about thermal pollution? The answer to that question is no. All right. So what have we learned about ponds in terms of how they perform? In fact, a 4 to 8 degree, I mean, that's a legit increase, I might add. In general, ponds work fine. I didn't even show you their peak flow mitigation because they do it. They're good. They're good at that. For water quality purposes, they're okay for some pollutants. They're certainly a lot better for sediment than, say, a dry pond is. I don't think there's any doubt about that. But for some pollutants, they're not as good. And one of the big ones that they're not as good with, in addition to thermal pollution and to some extent nitrogen removal, is they're not great at pathogen removal. Okay? And one of the key pollutants that we have across the globe are pathogens, and trying to make sure that we limit exposure to people to pathogens. All right. So ponds they're okay. They're better than dry ponds, but they could be improved. And so that is the reason why I'm eventually going to talk about constructed wetlands. But I did want to share some design standards that we use in North Carolina for wet ponds, because for many people, that a large pond with an open body of water is the ideal recreational feature to have. Okay, again, think about the construction outside of Delhi, these new, really fancy high-rise buildings. They want to have a place for people to go. And a pond may be what they pick, even though it may not be as good for pathogen removal. It's still good for sediment, and it can still look good. All right. So let's talk a little bit now about wet pond design. Y'all remember I talked about the aquatic shelf? I showed you that from the pond that was in Sweden. Well, here is a more defined aquatic shelf. And it's been determined that the aquatic shelf should be, this is 1.82, so whoop, about 2 meters, give or take, okay? About 2 meters long. All right? Now, why do you think it would make sense to have a vegetated shelf, plants growing up, that's 2 meters wide? What benefit does that give you? What do you guys think? Say, what's that?
The water level in the pond by evapotranspiration.
Okay, there is a modest evapotranspiration benefit, right? Because the vegetated area will have a little bit more. So there's it's a small benefit, but it is a benefit. Okay, that's one. Sediment load. There is a modest amount of additional pollutant removal that happens for any pollutants that find their way up onto the shelf. They're more apt to get trapped. Most pollutants don't find their way up onto the shelf, but those that do are apt to get trapped, more apt to get trapped, and so therefore there's a modest improvement in pollutant removal. What's that?
For security.
For security, yes, that is a benefit. And so the security is, if you have vegetation growing, it tends to be a way to keep people out. All right. If you don't want people to go into the pond, then you put a ring of vegetation on there and it keeps it out. Very good. I'm going to talk about why the shelf is 6 feet or 2 meters in a second. All right. Was there anyone else that has had? All right, hold on. What's this? In a row, actually, it does help with that. Without question, if you have well vegetated shelves, especially as it goes up the bank, you cut down on internal erosion. All right. And so it has a stability benefit. You guys did a great job. There is one more benefit that I don't think can relate to, well, you'll understand it, but I don't think it would happen here, is there's a bird in North America called the Canada goose. This bird, the Canada goose, it's got a big, when you were at Purdue, did you see Canada geese, long black necks with a white head? This big bird. Do y'all remember there was an airplane that crashed in the Hudson River of New York because it flew through a flock of birds? Well, those birds were Canada geese. They're big birds, all right? Well, Canada geese used to live where? Take a guess. Canada, right? They're called Canada geese for a reason. They used to live in Canada. But then they discovered the South of America. And like a lot of people, decided to move down there because it's warmer, reliably warmer, and there's lower taxes, okay? So the geese are like, we're not going to go back to Canada. They're like, we don't need their health care. We're good down here. But Canada geese, big birds, which means they have to do a lot of what? This is me trying to be a bird pretending to eat, okay? Canada geese eat a lot of grass. And if you eat a lot of grass, what are you then going to do? If you eat a lot of food, what are you going to do? You're going to process some of it and you're going to get rid of the rest. All right? So they eat and then they defecate all over the place, which is lousy, right? You walk around, you got to be careful where you step because you don't want to step in goose poop. Well, guess what, Canada geese? Guess what, Canada geese want to feel all the time? Just like all of us, almost all of us want to feel this way all the time. And that word is safe. Safe. And for you to feel safe, you need to be able to see. Well, guess what happens if you're a Canada goose in this pond, you got a bunch of vegetation growing up real high? What's happening here? The birds can't see. And it has been shown that if you put aquatic shelves around ponds, Canada geese will prefer to go to another pond. And that is a very big benefit for having vegetated. And so there's a pollutant removal benefit because you're basically not subjecting this water course to a bunch of goose poop. All right? FYI. Now, I mentioned, and it's on the screen here, that the aquatic shelf is 2 meters wide. Anyone want to guess why in America we would want it to be 2 meters? I mean, we could have it be 1 meter and be okay, right? 1 meter would be okay. Why do you think we need it to be 2 meters? Well, here it goes. Unlike in India, there's a fair number of Americans who drink alcohol. We do. That is part of that culture. The Europeans brought it over, and people drink alcohol. That's pretty common, including people who drink too much alcohol, which, by the way, is not very gentlemanly, but still happens. All right. And what do you think people who drink too much alcohol and get drunk, some fraction of them find their way to guess what type of stormwater control measure? A wet pond, right? So let's say you've got this drunk guy and he gets close to a wet pond and he falls in. All right. Bloop. Face first. Gets up. Is he drowning? He's not drowning, right? Gets up and he staggers and he wanders around. And then he falls again. And is he drowning? He's getting closer. If he gets up and falls one more time, then you know what? You guys know who Darwin is, right? That was just Darwin speaking. All right. So one of the jobs as a university professor is to come up with design guidance and design tools and ways to measure whether or not you've done your job. And that's what we did here. This could handle 5 drunk falls. And so you have a factor of safety and everything. So this is a very wide, very safe aquatic shelf. Okay, that's supposed to be funny. That's fine. Okay. 2 meters wide, roughly 3 meters deep. That's your typical wet pond design schematic. All right. 3 meters deep. Some people have them be shallower. I'd have them be deeper for pollutant removal purposes. 2 meter aquatic shelf width. If you do that, you have a safer system. All right. And a stable version, so you don't have as much erosion. Okay. One thing about aquatic shelves is they are living areas, right? You're putting plants in them, which means that their look is going to change. That was a 6-year growth. Isn't that amazing? What do plants want for living? They want water. They want nutrients. They want sunlight. What are we giving them in an aquatic shelf? Water, nutrients, sunlight, and those plants take off. All right. And there's a lot of nutrients that might have. So just be mindful of that aquatic shelves they can grow quite a bit. And that's going to hold true for, for wetlands as well. Now, how big does a wet pond need to be? We talked about this with sedimentation on Tuesday, but when you're thinking about how big a wet pond needs to be, really it's about is how much time do you want that water to be in your pond before it gets flushed out, okay? And that is referred to as the hydraulic retention time. Every single practice actually has a hydraulic retention time. We don't always calculate it, okay? So for example, for bioretention, which employs filtration, how much time do you need to expose filtration to a sediment particle that's about to get filtered? A second, right? It gets filtered and it's done, right? So a hydraulic retention time is particularly important if you're trying to remove pollutants through things like sedimentation or trying to remove it through denitrification. All right. So the hydraulic retention time basically is you pick your hydraulic residence time. That's 14 days. You look at your water quality volume. This is North Carolina standard, so in cubic foot, but you do the same thing in cubic meters. And you base that on your 35 millimeter rainfall that we calculated. And that will help you figure out how big your pond needs to be. In North Carolina, that pond volume is right at almost 3 times your water quality volume associated with 35 millimeters of rain. All right, that's how big your pond is. It's a relatively simple calculation. You just then figure that out, calculate what your average depth is. All right, and then boom, you've made your calculation. It's that easy. So what is your average depth? The average depth is allowed to range between 1 and 6 meters, okay? So now a lot of people are like, oh, well, let me divide my water quality volume by 6 meters, and what have you done to the size of your pond? If you know your volume is 2.8 times the water quality volume, and you divide that, so that's the volume. So what's your average size? Your size of the pond is your average depth multiplied into your water quality volume. All right. So if you're trying to make your pond as small as possible, and you're allowed to have your average depth range between 1 and 6 meters, what number are you picking? Let's think about that one for a smidge. Your surface area is 2.8 times your water quality volume. If you're a developer, many developers are like, hey, how much space we have to dedicate to that stormwater device? And you're like, hey, can I make that a little smaller? All right, because to them, space is money, right? So if it's up to the developer, perhaps not all of them, what depth are you going to divide into your water quality volume to figure out the surface area of your pond? Okay, I'll make you guys vote. You get a choice. I'm going to give you 3 of them. 1 meter, 3 meters, or 6 meters? How many of you divide your water quality depth by 1 meter to have as small a pond as possible? Right? How many of you divide by 3 meters to have as small a pond as possible? Okay. How many divide by 6 meters to have as small a pond as possible? How many of you are abstaining from this vote? There's some abstainers. Okay, well, let's go up on the chalkboard and get the answer to this question. Let's see how your gut did. All right. So SA of your wet pond is equal to is 2.8. So your volume is equal to your volume divided by your average depth of the water. Okay. volume of the water quality volume, okay? Water quality volume times 2.8, that's what that is, divided by your depth, all right? So in this, in particular, let me do this a little bit better. So your volume divided by your depth, and the volume is equal to 2.8 multiplied by your water quality volume, and you know that that water quality volume in rookies can be based off that associated with 35 millimeters of rain. Your depth, you can pick 1, 3, or 6 meters. Now that you've seen it in the equation, what's the right answer? If you want your pond to be as small as possible, surface area, what number are you going to use? 6 meters. All right. Now, while that might lead to the smallest pond possible, do you think that's a good idea? Do you want to have a pond that's 6 meters deep? Especially if it's a small one? What is that? That's a drowning hazard, right? And so there has been a secondary design guidance that says, we'll let you do that 6 meters, that you can actually have it be 6 meters if you want. But we're only going to let you divide by up to, they won't let you divide by 6. All right, that's too much. They even won't let you divide by 3. They're like, we'll let you divide by 2.5. 1 to 2.5. So guess what almost everyone divides their pond by? The pond volume is divided by 2.5 meters because that enables your pond to be as small as possible. But the 2.5 is picked in part because of safety, all right? It also has a pollutant removal benefit, which I won't get into. All right, so there you go. So if you're dividing a pond, there you go. I'm gonna skip through that. Okay, next. One of the things that we sometimes see is that the water will enter in and be actually very close to the exit. In this particular case, the water comes in over here. This is called a forebay, which is the first part of the pond that the water sees. Like we have a forenoon. This is a forebay. All right, the first part that the water sees. And then it spills over and goes through the pond and then leaves. That is a good design. All right, you want to make sure that the inlet and the outlet are not next door to each other. Here's the case where if you look pretty carefully, the inlet is right here. The facility wraps around to the side and the outlet's right here. They did not do a good job of having the inlet and the outlet be far apart. So that was not a good design. So again, the first place that the water comes in is called a forebay. This is actually a pretty important part of your pond's design. Because what do you think happens in the forebay? When water comes into the forebay, there's basically 2 things that are happening. So you have this water, it's coming in off your urban catchment. Often has a pretty high flow rate, which therefore, and it's in a constrained pipe, which means it has pretty high velocity. It comes into your pond, it hits that forebay. What does that pond do to that water right off the bat? What does that forebay rather do to the water right off the bat? It reduces the velocity of water. Without question. All this, and then hits this big pool. All right? The velocity of water slows down. Now, once the velocity of water slows down, what can it do? It deposits sediment. Yeah. It deposits coarse sediment. That's exactly right. God bless you. And so the forebay is designed to take the energy out of the water, slow the water down. Once it takes energy out of the water, the sediment that's being carried along with it falls, the coarse sediment falls out. and it collects in the forebay. Why don't you just let it go into the pond and bother? Why do you even bother with the forebay? Why don't you just let it go in the pond? It's going to fall out in the pond anyway. There's a reason. And the reason is if you keep having sediment fall out, eventually it has to be removed, maintained. And so forebays are very specifically designed for maintenance. All right? That they design them for maintenance, and they design to make sure that if you have an excavator or a track hoe show up, that you can take its arm and it's big enough that you can take it and you scoop out the coarse sediment and the trash that is accumulated. And that is the purpose of a forebay. And believe it or not, we've done some studies on forebays. Might not sound like a fun thing to study, but we've done it. And they do work. They are good. They're good. And in the United States, in North Carolina, but probably across the board in the United States, based upon how big we have our forebays, they tend to need to be scooped out once every 5 to 10 years. Knowing what I see here from a sediment load that I observe just generally, you're going to probably be scooping them out more frequently, every 2 to 5 years would be my guess. All right? But again, you're designing it so that the sediment is collecting in a place that you can maintain it. One of the most important things I can share with you as designers is that there's things you can do to make your practice more easily maintained. All right? And a forebay is probably the best thing you can do for a pond to make it more easily maintained. Because the easier you make the maintenance, you ready for this? The more likely it is to get maintained. It's human nature, right? One of the things I love about being a civil engineer, and look, if you're a hydraulic engineer or you're an ag engineer, you're part of the big family, all right? But being a civil engineer, civic, it's about people, it's about community, right? And therefore, civil engineers, more than probably any other, I don't want to diss anybody and make them feel bad, but I feel pretty confident saying this. Civil engineers, more than any other engineering discipline, have to understand how communities work, right? You have to understand psyche, people's psyche. Like I obviously, well, I didn't study philosophy. I didn't study sociology. That's interesting. But it was still working. But I actually think those are good minors to have if you're going to be a civil engineer, because it helps you understand the community with which you're working. It's a lot different from being an aerospace engineer where you're designing rockets. And that's cool, but you really don't have to worry about what the community thinks about your rocket, do you? But as a civil engineer, you better think about the community. Can you use fountains? Why would people use a fountain in a pond? Because it looks good. There's another big benefit, though. A big benefit to having a fountain in a pond. When the fountain's going up and the water lands, what happens when when the fountain water impacts the pond pool? What do you get? Is it perfectly still? Nope. Water comes up, comes down, hits a pool, and creates a wave. So it's not a big wave, it's a little bitty wave, which is part of the reason why I think you mentioned the stability that the aquatic shelf gives you. Is you have a little wave action that would cause erosion, all right? But when you have all the vegetation that's accepting that very modest wave action, very modest, it eliminates or really severely limits the erosion, all right? You know who doesn't like wave action? I'll give you a hint. I think I heard you say it. I wasn't being mad at myself. What is it? Ow. Mosquitoes. That's right. And so again, do you think when you build one of these big new developments outside of Delhi with all these 30-story buildings, and you've got your centerpiece stormwater feature, a pond, you've got thousands of people looking at that pond, what do you want to bet that some of them are like, I think there's mosquitoes in that pond. Right? There's mosquitoes in that, and they're going to complain because remember, civil engineering, we're dealing with people, society. There's mosquitoes in the pond, okay? You're like, hey, we got a fountain in it. The fountain really does make it very difficult for mosquitoes. It really does make it very difficult for mosquitoes to live. It doesn't mean it's mosquitoes can live there, but you will not have a mosquito breeding ground. That is a really important feature of a fountain in a pond. Now, not every pond gets a fountain, but I'm just thinking about these new developments that some of you are going to be working on and designing and making, to be beautiful and functional. You also want them to be mosquito resistant. Okay, so that's a really important reason to have a fountain. All right, next, trash racks. You understand why we have trash racks? You need them because what will happen if you don't have those racks, they'll get into the orifice and clog it. And then you've got flow issues. Now, one of the things I've observed with trash racks is they themselves do eventually collect so much trash that they obstruct flow. You need to have people frequently look at the trash racks here, especially on these big facilities. Because if the flow gets obstructed, then the water level rises, and then you start having hydraulic grade line issues the next time a storm comes. There's a whole bunch of these things that can be bad if the trash rack collects too much trash and does not get cleaned. Okay, so you need to make sure. And one thing I've observed here at IIT is the staff here is out there making sure things are working right. I've observed it all the time. There's people all over this campus making it look nice, making it look attractive, keeping it clean. In these new developments, I would guess that there's going to be some staff that will be responsible for the grounds. You want to make sure that they know to look at the wet pond to make sure that the trash rack is freely flowing. And that may be a monthly thing that they do, maybe a weekly thing. I don't know. What types of vegetation can you put in them? On the dam, you don't want any, all right? And they want to have different species growing. You don't want to have a monoculture. That's essentially what that's about. Okay, so ponds, what are they good for? They're good for peak flow mitigation. And they're good for removing pollutants. And if you want them to be, they can be aesthetic, they can be recreational amenities. Aesthetics meet aesthetic amenities or recreational amenities. So those are all the reasons that ponds get used, all right? You will have ponds. I just cannot imagine you won't. You will have ponds. But for some of those other pollutants that ponds struggle to remove, that gets us to the world of constructed stormwater wetlands. And I think what I'm going to do is I think we're going to take our break here. All right? We're going to take our break here. It's right at, according to that clock, 11. According to my phone, it's 11:07. Let's take a 15-minute break. Or when that clock says it's 11:15, so that means 11:23. And we'll crank back up then. All right? We'll talk about wetlands as soon as we get back. Assume we have tea. Everything's ready outside. Perfect. All right, let's enjoy our tea. I'm speaking of that, I'm going to get some more for me.